My name is Professor Matt DeGoosh, and I'm the Associate Dean Research of the Faculty of Engineering, Architecture and Information Technology. It's my pleasure to be hosting you this evening for the UQ Frank White Memorial Lecture. Before we start, I would like to acknowledge the traditional owners and their custodianship of the lands on which we meet today. And I would like to pay my respects to their ancestors and their descendants as we walk together on the path to reconciliation. I would also like to extend a warm welcome to Professor Sue Harrison, Deputy Vice-Chancellor of Research and Innovation, who you will hear from shortly. Emeritus Professor Don McKee, keynote speaker Kate West, Chief Officer APAC at Arup, UQ colleagues, students, alumni and the industry partners, distinguished guests one and all. Before we begin our formal proceedings, a few basic housekeeping items. The bathrooms are located through the doors at the back of the room and on the other side of the foyer. In the unlikely case of an emergency, please exit via your nearest exit point and follow instructions from the Customs House staff. We gathered here tonight to celebrate the enduring legacy of Professor White, Frank White, a pioneering figure whose vision and leadership laid the foundations for mining and metallurgical engineering at UQ. This lecture was first established in 2023 to honour his lifetime of service and to continue the conversations he championed about innovation, integrity, and the key role of engineering in shaping a better future. This event was first conceived by Emeritus Professor Don McKee and Dr. Bob Bryan AM, and we're honoured to have Don with us again this evening whilst Bob sends his apologies. Even as the Frank White Memorial Lecture's mission is rooted in the values of its namesake, it is much more than a tribute. It's intended as a signature UQ event that brings together disciplines from across the engineering sector to explore the grand challenges of our time and engage in important discussions about how leadership and innovation in engineering can help us navigate them. I have no doubt that tonight's keynote will spark fresh thinking and meaningful discussion. So before we begin the lecture, I would like to firstly introduce UQ Deputy Vice-Chancellor of Research and Innovation, Professor Sue Harrison, to say a few words and introduce our keynote speaker. With over 30 years in senior academic roles at UQ and the University of Cape Town, South Africa, Professor Harrison has a strong commitment to strategy, research discovery, innovation and translation. From 2024 to 25, she served as Executive Dean of the Faculty of Engineering, Architecture and Information Technology at UQ. And in her current role, Professor Harrison leads strategies to enhance the university's research and research training frameworks and is focused on expanding strategic partnerships with industry and government to deliver outcomes that benefit communities, the economy and the environment. So please welcome Sue.
So thanks, Matthew, and thanks for the introduction. I too would like to acknowledge the traditional owners and their custodianship of the lands on which we meet today, and I pay my respects to their ancestors and descendants as we walk together on the path towards reconciliation. And I'd like to welcome and acknowledge Ms. Kate West, Chief Officer of APAC, Business and Markets at Arup. I'd like to welcome you, friends and donors of UQ, and UQ colleagues and distinguished guests. It's really a great pleasure to welcome you to Brisbane's Customs House for the 2026 Frank White Memorial Lecture. And I think we all enjoy coming to this venue and just being able to relax a bit and take in the inspiration of the day and the ability to connect with each other and network a bit. This annual lecture, as Matt said, was established in 2023 to honour a remarkable legacy of Professor Frank T.M. White, a pioneering figure whose career transformed the practice of the teaching and practice of mining and metallurgy at the University of Queensland. Frank arrived at the University of Queensland in 1950 as the university's first professor of mining and metallurgy. In that role, he not only built a department from ground up, but embedded values that were decades ahead of their time. Values of diversity, sustainability, and a recognition that engineering should serve society as well as industry. And I often think about these people who built university departments from ground up, because we always come into roles which are so well organized around us. It must be really exciting and really so challenging. But I think that it's important just to think through that approach that he had, that approach around diversity, sustainability, and recognizing the need for engineers to serve society as well as industry. His early professional life had taken him from the goldfields of Western Australia to the Department of Mines in Fiji, to post-war Malaya, where he helped to rehabilitate the tin industry and contributed to the nation's mining laws. And so tin should mean something to us, because these experiences helped shape his global outlook, but they also, we note tin and Indrapuli. So. Frank was an advocate for inclusion long before it became commonplace. So he championed international education, helping to establish International House at St. Lucia, and he actively supported women in a male-dominated field, including employing the first female academic in his faculty and encouraging the first woman to graduate in mining engineering at UQ. He also had a visionary approach to teaching and research. And so the tin, not tin silver, I got it wrong. Where others saw an abandoned silver mine at Indrapuli, Frank saw a world-class experimental laboratory. And that mine became the Julius Krishna Mineral Research Center, today an education and research facility recognized globally for its innovation and impact. And so there's no exaggeration to say that much of UQ's standing in the field of mining and metallurgy. We currently are ranked 5th in the world in mineral and mining engineering. That reputation is built on foundations that Frank White laid more than 70 years ago. So the values that Frank stood for during his career here of education, leadership, and transformational thinking are just as vital today, and we talk about them a lot today. They're at the heart of UQ's own strategy to create change for a better world through excellence in teaching, research, and engagement. And this means driving innovation not only through disciplines, but across them, whether through new technology or smarter partnerships or rethinking the way we prepare students and industry for the future. Innovation isn't an abstract concept at UQ. It's part of the way that we work with industry and with our communities to turn knowledge into impact. And so thinking about knowledge and impact brings me to our keynote speaker this evening, Ms. Kate West. Kate is the Chief Officer APAC, Business and Markets at Arup, and has 25 years of international experience spanning infrastructure and the built environment. As Chief Officer of Arup, Business and Markets, Kate sets the direction for business growth, innovation, and market diversification across 6,500 professionals at Arup in the Asia Pacific. Kate's achievements are widely recognized, being named as the Australian Financial Review Women in Leadership Award winner in 2024, honored as a National Honorary Fellow by Engineers Australia, and appointed as a Fellow of the Australian Academy of Technology, Science and Engineering in 2025. Kate's topic tonight, what's next for engineering, beyond the unbuildable, couldn't be more timely. We're all living in an era defined by rapid technological change, interconnected systems, and an urgent need for a holistic approach to problem solving. And in her address tonight, Kate will highlight the growing importance of engineers as integrators of systems and the opportunity for emerging talent to combine technical excellence with curiosity and adaptability. And so it's with great pleasure that I welcome Kate to deliver the 2026 Frank White Memorial Lecture. Thank you.
Thanks so much, Professor Sue Harrison, for that very generous introduction. And thank you all for joining us here tonight for the Frank White Memorial Lecture. It's my absolute pleasure to be joining you in Brisbane, one of my favourite cities in the world. It's so energised at the moment. It's a great place to come. And in such a beautiful venue. I've never been to Customs House before, so certainly an absolute pleasure to be here this evening. Before I start, I'd like to just make sure I'm moving the slides on. I'd like to start by acknowledging the traditional owners on the land on which we gather, the Turrbal and Yarraga people. Their deep knowledge, creativity and stewardship of country reminds us that design in all of its forms, is never just technical, it's cultural. So it is my absolute pleasure to be delivering this year's Frank White Memorial Lecture. I do want to start by acknowledging the legacy of Professor Frank White, whose contribution to engineering, education and public life, as we heard from Professor Harrison, continues to inspire this lecture series as well as the University of Queensland.
And I would also like to give my thanks to the University of Queensland for the invitation to speak this evening, and also for the long and trusted relationship that we have between Arup and UQ over many decades now, working together, doing research together, and certainly to you for providing us many of the brilliant Arupians who now work with us around the world. As an engineer, I had the great joy of working all over the world, myself delivering amazing projects and working with some of the most remarkable people. And through this experience, my understanding of what engineering is and can be to society has grown, how it contributes to people and society and the planet.
I started as a young engineer with a deep technical appreciation of engineering. I loved maths, I loved physics, I was very focused on the detailed design process. But it's certainly grown today to a much broader lens, where I see engineering delivering as a system of systems deeply embedded into the fabric of our society and planet. And this evening, I'd like to share some of my experiences, some of my reflections with you that have shaped this perspective, and to discuss how I believe engineering is going to continue to evolve into the future, and how the profession is absolutely rising to the challenges that we're facing today as a society. And on that topic of building the unbuildable, reflect on why I think there's probably never been a more exciting time to be part of this profession. So, on to the topic of building the unbuildable. I graduated with my undergraduate degree in engineering from the University of Western Australia back in the late 1990s. And as a young engineer, I was full of curiosity. I was a little bit restless, but I was also intent on doing good in the world. And we were just talking earlier this evening about this sense of purpose that is continuing to drive our students and young engineers today. And I certainly wanted to use my engineering skills to make a positive difference in the world. But I also wanted to see the world. As many people in WA at that time, I was quite keen on moving on.
And so I joined Arup. Arup, an independent global company, owned in trust by its staff, whose stated purpose was and still is simply to shape a better world.
And more importantly for me at that time as a young engineer, they had this fantastic strapline, which was start here, go anywhere. And I certainly joined with my bags packed, ready to be paid to work as an engineer around the world, which certainly I embraced, and I'll share some of those experiences tonight. And it's what's kept me here 25 years later to continue working with this extraordinary firm, with our clients and partners to do good in the world. I think, on a serious note, other than the sort of free ticket around the world, what also drew me to Arup was this extraordinary legacy of projects that we'd been involved with, from the Sydney Opera House to the Kansai International Airport in Japan that was built on a reclaimed island, to the Centre Pompidou in Paris, these extraordinary projects that at the time you might have thought were unbuildable, but through engineering excellence, through collaboration, through ingenuity, we absolutely brought to life. So there is certainly one project that stands above many others in the firm's history, which I'd like to share with you, which is the Sydney Opera House, which I've personally got a strong connection and history with, because we continue to do almost all of the engineering today, 50 years after it opened. And it was our first project here in Australia. And I reflect, it's actually hard when you fly into Sydney today, it's hard to imagine Sydney without the Opera House. It's sort of the defining feature of the city. It feels almost inevitable, a global icon which really identifies Sydney on the global stage. But I think what was remarkable for many years before it came into existence, it certainly was not considered inevitable. And in fact, actually for many years after Jorn Utzon drew the sketches, it was actually considered quite impossible. And Jorn Utzon sort of conceived, you can see here these sweeping sails, you know, this vision of the architecture. And yet the engineering at the time was not available to actually bring this structure to life. And that was where Arup and his team of engineers came in. So from the UK, they collaborated deeply with Jorn Utzon, tested new material design, tested different ways of construction, really building on that deep collaboration to fundamentally bring a vision to life that had previously been unbuildable. And it is absolutely a story of technical excellence, there is no doubt. You go into our office in Sydney and we still have the original drawings and design calculations in the office. But actually it was a story of remarkable collaboration, testing and challenging each other, such that the whole was more than the sum of the parts, and nobody alone could have delivered this extraordinary vision that we now see. My own first project with Arup was no Sydney Opera House. It was, in fact, this minuscule little bell tower in the city of Perth. It was beautiful in its own way, but it was a fraction of the size and complexity. But to me, it was wonderful as a young structural engineer joining Arup. It was my opportunity to work with architects, to draw, to design, and then see come to life the vision that I had been involved with creating. And I can tell you, it was an extraordinary feeling to see my handprint manifest on the form of the city around me. And still today, one of my greatest joys is seeing the buildings, seeing the infrastructure I've been involved in designing, being used and loved by people around the world. It is extraordinary. My children often remind me that I feel in many ways as connected to my projects as I do to them. But ultimately for me at the time, the bell tower was just a singular project, and I was very keen to extend my impact, to extend my reach, that sort of purpose of doing good in the world, and have a greater level of involvement in systems and broader networks. And that then took me to the far remote northwest of Australia. And this is a picture of me as a young 20-something engineer in Emu Creek community, where I was sent, this is the days before health and safety, as a young 24-year-old, I was put on a light aircraft with a swag on my back and sent out for a week in the community by myself. And I was sent to fix a failed wastewater system, which probably doesn't sound like the most glamorous challenge in the world, but it was an extraordinary opportunity. And if there's been one lesson in life for me, it is seize those opportunities. And I'd say to all of our young students and engineers here, it is those opportunities that you don't expect, those doors that open, I would absolutely encourage you to embrace and take, because you don't know where it's going to lead you. And this was absolutely one of those projects. So I arrived in Emu Creek, starry-eyed young engineer with this failed septic wastewater system, and I was focused on the technical challenge. I was considering how would we build this new wastewater system in the middle of nowhere? How would we get the infrastructure in? How would we get the technology in? How would we maintain it through the absolutely inhospitable wet season? How would we design something that could withstand these extraordinary climatic conditions? But it quickly became apparent to me through the early conversations that I had with, you can see there in the photo, a number of the community, that this project was so much more to them. It was an opportunity to create infrastructure that they could take ownership of, an opportunity to gain employment for the community members through the construction phase, through the asset management phases of the life of the infrastructure, And ultimately, actually at its root cause, it was the opportunity to create better health outcomes for a community that had suffered for years with a range of medical conditions from this failed wastewater system. And so again, my lens on what my role as an engineer was widened. So it went from fixing a wastewater system to really making this deep contribution to this community. And I was embracing it then as a social development opportunity. And through this deep collaboration with the community, we ultimately delivered a solution that we called wastewater gardens. And at the time, it was the first time that this had been done, certainly in Western Australia, possibly more broadly. And it created a natural solution, one that worked with very, very robust technology, and it created much better social and economic outcomes. And for the Emu Creek community, and I went and visited them many years later, they actually loved these wastewater gardens. It wasn't just that it provided a functional solution, they actually loved the infrastructure. And I actually think for me, you know, this talking about love of what we do, the joy, the beauty, but that deep connection and commitment with what we actually deliver as engineers really gives me great purpose. And I think it cemented my thinking early on that success as engineers is not judged by the engineering solution only, but how it delivers broader outcomes for the communities and the societies that we work with. And ultimately, there really is the opportunity for our infrastructure to deliver healthier, happier, more joyful communities, which continues to get me out of bed. And actually, as designers, as planners, we need to be thinking of these types of problems not as individual challenges and projects, but actually as this system of systems. And no one of us can deliver any of this infrastructure in isolation. And ultimately, for me, I really did learn at this stage, the most effective engineering solutions start not with the question of what should we build, but what outcomes are we actually trying to achieve? So I went from probably the smallest project in my career to the very largest project of my career. So a couple of years later, I was still using my free Arup aeroplane ticket around the world. I had been over to London for a few years.
Thank you.
And Arup then won the biggest design competition that had ever entered, which was to build a new terminal and airfield and transport system at Dublin Airport. So we came in as the lead consultants. We led a team of construction managers, architects, specialists, and we came in as the lead consultants to build a new 75,000 square metre terminal, new landside transport infrastructure, airport stands, energy systems, and facilities capable of serving up to 15 million passengers per year. And certainly, you know, it was envisaged that millions and millions of people would certainly pass through this front door to Ireland over its lifetime. And at this stage, I was in my late 20s, so I'd been sleeping in the swag at Emu Creek, and I'd sort of, you know, grown up a little bit, but I had no experience working in Ireland. I'd not delivered any airports. And I was offered this role to take on the deputy design team leader for this entire project. So as 2IC, and I was incredibly excited, but also somewhat daunted. And initially, and it's probably a theme of my career, I almost said no. And then I thought, why not? Give it a go. And again, to any of the sort of young engineers in the room, do say yes to these opportunities. They grow and they extend you, and you're often your own worst critic. So really do embrace these new experiences. And for me, the responsibility felt enormous, and I felt at this stage of my career that I wasn't ready yet to lead. I saw leaders as people who were grey-haired, you know, at least 30 years sort of on from where I was at the time, people that had all of the answers. You know, surely that wasn't me. But then I realised that actually the success wasn't reliant on me alone. It was going to depend on bringing together the architects, bringing together the engineers, the planners, the construction specialists, the airlines, the operators, ultimately the client, to all work together to ultimately deliver this shared vision. And the challenge wasn't simply building this terminal, it was again designing this system of systems. And this huge sort of complexity and integration that we needed to deliver was not coming from me alone having all the answers, but my role connecting people and bringing together different perspectives and different expertise to deliver what is ultimately probably one of the projects that I am most proud of. On the back of Dublin Airport, and after more than a decade working as an engineer, I went back to university and embarked on a Masters of Architecture at Cambridge in the UK, where Sue and I have just realised we've got a common connection studying at the same school. And the decision surprised some people because I actually had not been the best undergraduate student in the world. I certainly wasn't very studious. I enjoyed the social aspects of uni far more than the academic when I went through engineering. But I had realised something important in my 10 years of engineering, and that was that the projects that had impacted me most throughout my career were successful because of the talented people that came together to deliver the projects. In the remote First Nations communities, I'd learnt that infrastructure only succeeds when it genuinely responds to the needs of the community and the specific place that we were working in. On Dublin Airport, I'd seen firsthand that projects of real scale depend not only on engineers or architects, but on the contractors, the operators and the clients working together. And so as a mature age student, I really wanted to round my education out and study architecture to build and deepen my understanding of the multitude of perspectives that affect a project, and to be able to personally be better able to balance, prioritise and ultimately optimise the inputs so that the whole was more than just the sum of the parts. And the study of architecture really did fundamentally develop my thinking as an engineer. I know as engineers we always think we have all the answers, but there was certainly a sort of deepening and evolution from there, that moving beyond seeing projects in this quite linear way, architecture encouraged me to sort of stand back on the balcony, to look out, to synthesise the various components and to see the bigger picture, to understand that every design decision really does sit within a broader context, that buildings sit within precincts, precincts sit within cities, cities sit within broader economic, social and environmental systems, and that the best outcomes really do emerge when we design to reflect all of those connections. And this experience certainly helped to develop my thinking, my understanding of Arup's philosophy. At the time, he talked in the 1940s about total architecture. He in fact wrote some quite philosophical speeches. He was a philosopher actually before he was an engineer, around total design. And at its core, total design is a simple idea, and certainly it's not unique to Arup. It acknowledges that the most complex projects are rarely solved by a single discipline alone. The best solutions when we bring together this myriad of expertise and perspectives and experiences to understand the whole challenge, to reflect on the whole challenge before we actually embark on designing the answer, which I often reflect, with my team and with the projects we work on. The theory is so clear, the theory is so solid, and yet it's so often hard to do in practice. But it certainly was the philosophy that helped to transform Jorn Utsen's vision for the Sydney Opera House from this ambitious sketch of these beautiful sails into the reality that we see now with bricks or tiles, in that case, and mortar. And I do believe it's more necessary today than ever. The challenges that face us, and we talk about this often, are becoming more complex. We've got climate change, energy transition. I met with some of the contractors today working on some of the most remarkable energy transition projects in Australia. Housing affordability, nature loss, rapid population growth, supply chain disruptions, the opportunity for digital transformation. And none of these challenges sit neatly within the bounds of a single discipline or in the bounds of a single solution. And total design really reflects this mindset, this way of working, this way of thinking that brings together deep technical expertise, yes, but with diverse perspectives, digital capability, and fundamentally deep creativity to generate better outcomes. And I think actually at its root cause, and certainly for me as I've matured in my career, fundamentally to challenge us to ask better questions, to really more deeply understand the consequences of what we do, to explore trade-offs, to see connections, and recognise that every project really does sit within a much larger system. And I'm seeing this more and more with the recent projects that I've been involved with the Arup team around the world. And the first one I wanted to share with you tonight, the Kaitak Stadium and Sports Park that you can see here, is an absolutely fantastic demonstration of this total design mindset. I was recently there with the client and the team watching the rugby sevens, which was great. It's always nice to use the infrastructure that we design. But the project brought together architecture, engineering, hugely complex acoustics, sustainability and operations to balance multiple objectives, and ultimately delivered this world-class spectator experience, created an iconic landmark which has been really critical for Hong Kong, and they've had quite a challenging chapter. So this kind of absolute burgeoning new chapter for Hong Kong. And it ultimately has reshaped the heart of Hong Kong. For those of you that know the city, Kai Tak was in fact the old airport. So aeroplanes for many years landed here. And when the city thought to rebirth the airport to move it out of the CBD, this opportunity of what could that site be certainly challenged thinking, and I think has delivered this incredible civic sporting heart into the centre of Hong Kong. Another project, and those of you who know me know that I am absolutely passionate about the transport sector and the role that it plays in shaping our cities. And for me, I was personally quite deeply involved in this project for many years, the Morley-Ellenbrook rail line in Perth. And it certainly combined engineering, architecture, planning, urban design, sustainability, to address a wide range of challenges. And many years ago, we probably would have thought about this as a railway line, railway stations, but ultimately this was about land development. It was about moving people onto public transport, lifting utilisation of public transport, creating a more decarbonised transport network for a city like Perth where everybody loves their cars, and actually ultimately pushing forward this idea of transit-oriented development and densification. So again, as engineers, and I remind our rail engineers so often, you know, they are an important golden thread in fundamentally shaping the feel and the way of working of our cities. And another project that is quite dear to my heart is Marina Bay Sands, which you can see here. And a marvel of structural engineering. Having started my life as a structural engineer, I still get a kick out of seeing some of these projects. And you can see a photo there. I was just there a couple of months ago with my youngest son, Tom, who gets a kick out of telling everyone about all the projects that his mum single-handedly delivered around the world. But it was an incredible project, you know, and it was one that really took us to the edge of our engineering excellence. As an organisation, I remember many sleepless nights. There was many stressful moments. There were some things that didn't go quite to plan without sharing all of our dirty laundry. But actually, often through those toughest of moments, those things that actually don't go quite to plan, you learn the most. How do you solve things when you're on site, it's not going to plan? How do you bring the contractors in? How do you bring the designers in and look for novel solutions? And certainly this building delivered that in spades. And so all of these projects that I've just shared with you are very different countries, different clients, different technical challenges, but they have absolutely benefited from this mindset that I call total design. And the mindset is more important today than ever. Today's engineers are not just being asked to solve isolated technical problems, we're being asked to solve interconnected human problems. Really at its heart, it's human problems. We need technical expertise, certainly, to all the students here. There's no getting out of actually doing the work, getting through those exams. But actually, importantly, you need creativity, you need collaboration, you need empathy and an ability to see relationships between sectors, between disciplines, a project and its wider context. And in many ways, I believe that this is the defining challenge facing our profession today. Like Jorn Utzon, like Ove Arup back with the Sydney Opera House, every generation of engineers inherits its own version of the unbuildable. For Ove Arup's generation, leaning into unbuildable projects like Sydney Opera House, they had these deep technical challenges that they need to unlock. How do you build something that's never been built before? How do you turn an architect's extraordinary, dare I say it, crazy vision into reality? How do you make the impossible possible? But the modern unbuildable for me looks quite different today. Today, you know, we do have extraordinary design capability. We know how to build remarkable buildings, how to build hospitals, schools, railways, airports, sports venues. The technology is here, but for me the challenge is no longer the individual asset, but the complexity of unlocking the value of the totality of the systems that surround the project. Take housing. We know how to build houses. The technical challenge isn't holding us back individually, and yet housing remains one of the absolute defining challenges for us in Australia now, in this time. And the challenge here lies with bringing together a complex web of economics, planning, infrastructure and community expectations, dealing with rising labour costs and material costs, dealing with supply chain infrastructure delays, transport planning systems, transport-oriented developments, shaping where homes can be built. Communities rightly want growth to be accompanied not just by housing, but by transport, schools, healthcare, and quality public spaces. And again, none of these can be solved by engineers alone. High-speed rail, another project that I'm absolutely enjoying being involved with in Asia at the moment, as well as, of course, this work in Australia. In the past, high-speed rail success might have been measured by whether the railway was delivered on time, on budget, but today that's just the starting point. We're increasingly being asked, what happens next? Does the railway support new housing where that housing is needed most? Does it connect people to the jobs and opportunities that they're looking for? Does it help regional communities to thrive? Does it improve productivity and the quality of life? Increasingly, as engineers, we're not just being asked whether something can be built, but we're asked if it delivers the greatest value for generations in years to come. And I think perhaps nowhere is this more evident than here in Queensland. And I couldn't speak to you tonight without touching on your extraordinary Olympics. And I have to say, the energy around the Olympics, I just walked past the countdown clock, which is counting down in seconds, 5 years, and then, we were seeing the seconds as we walked past. And there was something about seeing the clock in the mall today that actually really just hit me, emotionally. This is really exciting. And I think for me, the Brisbane 2032 Olympics and Paralympic Games are often talked about as a sporting event, but to the teams, some of whom are here tonight, delivering these projects, they know that they are working on something much, much bigger. As we've seen clearly over the last week with the release of the Victoria Park Legacy Plan and Vision, and doesn't it look gorgeous? The Games represent a once-in-a-generation opportunity to reimagine the future of Brisbane and the wider state in a way that will deliver value to Queenslanders for many, many years to come. And I think it's wonderful to see the investment in infrastructure required to support the Games being used to optimise transport networks, being used to create connecting housing precincts, world-leading public spaces, digital infrastructure, economic development, and ultimately environmental outcomes. Because the success of Brisbane in 2032 will ultimately not be judged by what is simply built for the Games itself. Of course, that's important to anyone here that's actually responsible for the Games, but actually the legacy that this infrastructure will leave behind for Brisbane for decades and decades to come will be the hallmark of its success. And that requires us to think beyond each individual project that will make up the Games, because cities are no longer simply a collection of assets, but it is also an interconnected system. Transport influences housing, housing influences productivity, productivity influences prosperity, and fundamentally energy, water, technology, nature, community wellbeing are all interconnected. And every decision that we make as designers fundamentally creates consequences elsewhere. And I do believe there's never been a more exciting time to be an engineer. For the young engineers in the room, you have got an extraordinary future ahead of you. We're no longer designing assets, but increasingly we are shaping the systems of systems. And that brings me to my next question, which is, if this is the role that engineers play today, what will it mean to be an engineer in 20 years' time? What skills will matter most, and what challenges will fundamentally define the next decades of engineers? Certainly from where I stand, the tools available to this next generation of engineers will be more powerful than anything I have ever seen. There's a great deal of discussion at the moment, of course, around AI and the potential impacts, its potential to improve productivity, the questions around the impacts on the profession and the future role of the designer. But I am by nature personally an optimist, and it's actually not hard to be optimistic about the opportunity of AI. In my capacity as a leader of this very large, extraordinary engineering firm, I believe the question is one fundamentally of upside opportunity. And our focus is on how to embrace the opportunity of AI. We are seeing it sprinkled throughout workflows in everything that we are doing. And fundamentally, my role is to help navigate this change and this opportunity for all of our people. Because as technology becomes more capable, the questions that we as engineers face become less about calculation, and my younger self, who was not very studious, would delight in this. It's less about processing information and more about the deeply human ability to make judgments and to understand what matters. Because design at its heart for me is a profoundly human endeavour. It's about how people feel when they walk into a space like this beautiful customs house that we're in tonight. It's about connection, belonging, comfort and delight, about solving problems in a way that actually makes life better. And I believe the challenges that lie ahead will demand more than simply technical expertise. And perhaps the most important skill in the future will not be knowing all the answers, but actually knowing how to ask the right questions. How to balance economic growth with social equity. How could we reconcile competing priorities across generations? How can we harness new technologies while preserving the qualities that make places livable, inclusive, resilient? And how do we ensure that progress fundamentally benefits everyone in society? And these aren't purely engineering questions, but engineers have got an essential role in shaping the solutions and helping to society to answer these questions. I had this wonderful colleague, he's not yet passed, Tristram Carfrae, one of the world's leading structural engineers, an extraordinary man. He's just helped to complete the Sagrada Familia in Barcelona, topping it out after 185 years. And he often reminds me, people cherish the things that they love. You know, and I go back to the wastewater gardens at Emu Creek community. They cherish the infrastructure that they love, that they feel involved with, that they feel committed to. So even in a world of digital disruption, automation, AI, the design that truly resonates, the design that will bring people great joy and connection, a feeling of love, will ultimately always require human creativity at its core. Technology will accelerate ideas, absolutely, but it won't replace imagination. We will absolutely need empathy and deep human connection, qualities that as engineers we absolutely can bring in determining the kind of future we want to create. And I believe that if this is true, if our humanity becomes more important in the decades ahead, then I think the future of engineering will be incredibly bright. Which brings me to my final reflection tonight. Whether you're a student considering your future, or an experienced practitioner, or even one of the many leaders that I can see in the audience tonight, navigating complex challenges. What unites us, I believe, as engineers, is the deep belief that we can make a positive difference to this world that we're living in. And this evening, I hope that I've reinforced that engineering is not simply about solving an individual technical problem. It is about helping to society to navigate complexity and increasingly bringing together disciplines, bringing together perspectives and people to shape better outcomes for future generations. And I think certainly the legacy of Professor Frank White speaks to this, and I think is certainly alive and well in the many engineers amongst us. The challenges ahead will be significant, but every generation inherits its own version of the unbuildable, and every generation can take the opportunity to redefine what is possible and what contribution it wants to make. And I personally remain deeply optimistic because I see the talent, I see the creativity, and I fundamentally see the commitment in the engineering profession. I see engineers who are willing to think beyond traditional boundaries, who are as interested in people and communities as in technical solutions and projects. The future will not be shaped by technology alone. It will be shaped fundamentally by people like us, because the future is going to be absolutely in the hands of the engineers, the planners, the designers, the contractors that we work and deeply collaborate with day in and day out. I'll leave that there. Thank you so much again for the opportunity to give the Frank White Memorial Lecture this evening. And I think we are now going to a Q&A. Thank you all.
Thank you for delivering such an engaging presentation, Kate, and such a positive outlook. I would now like to invite Professor Tim Castile to the stage to facilitate our question and answer session. Tim is the Director of UQ's Liveris Academy for Leadership and Innovation. The Academy's mission is educating students with demonstrated leadership prowess, a passion for sustainability and the potential to solve problems through large-scale innovation. With the Academy also taking leadership in sustainability and innovation both locally and globally. We have a number of our Liveris scholars in the audience tonight too, which is great to see. So I'll hand over to Tim. Thank you, Tim.
Thank you, Matt. Thank you, Kate, for such a terrific talk. It was wonderful to hear about I think the thing that really struck home for me was the idea that a lot of these problems aren't just technical, they're actually human. And I think that's a really important thing for people to be taking away from it. So now we've got time for questions for people. We'll start by prioritizing questions from students for a little bit, and then given time, we'll broaden out after that. So we're open for questions. Yeah, let's start with Matilda.
When you started your career out of university, obviously going in with a lot of that technical expertise and suddenly entering a workforce where lots of other skills were necessary and part of the role, what surprised you most about your new role?
Yeah, great question. Yeah, I mean, you spend so much time, or certainly I did sort of back in the dark ages, 25, 30 years ago at engineering school, doing maths, doing physics, and I sort of, you're deeply focused on, I think in many ways, the sort of individual work that you were doing. So what really surprised me when I got into the workforce was the deep collaboration needed. So this bell tower project that I worked on, it was extraordinarily complex. And so actually realising that it wasn't just about me going off into my dark room, with my, computer model then and working out how to design the structural form of the building. Actually, it was this deeply sort of connected sport almost of working with the architects, working with the contractors, working with the clients. And actually I was delighted. As quite a social person, I was thrilled that actually I was in a profession where actually the time that I needed to spend with other people together collaborating was huge. So I think for me it was a great joy realising that actually this was a team sport that I'd entered, not a solo race.
Thank you for your great lecture today. I really enjoyed it. I'm also very interested in maths and physics specifically, and also looking into engineering in my future. But like with AI and that, will that be impacting obviously the maths and physics aspect of engineering? How will that impact that?
Yeah, great question. So look, I mean, we're sort of, and again, none of us has all the solutions. What's the great thing about AI is it's this real leveler, and we're working at pace to try and understand how we best use it, how we best embrace it, and we're sort of learning as we go and changing and optimising our approach with AI. So there's no doubt that it will automate some of the work that as engineers we traditionally did. So, when we used to get out our slide rules, and, that's certainly demonstrating my age, we sort of, used to get the scientific calculators out and do a lot of the work, and even more recently, had Excel spreadsheets. Those processes will change. So actually a lot of that can get automated. But actually that's a great opportunity for engineers then to use that knowledge of physics, of maths in a higher order way. So I think it's still really fundamental. My 16-year-old son very proudly told me the other day, actually he didn't need to learn maths anymore. Whatever he's going to do, actually AI could do the maths for him. And sorry, sweetheart, you're still going to need to know the maths. You're still going to need to know the fundamental principles of physics. You won't probably need to do all of those calculations. We'll be able to workflow that through with AI, get much faster inputs. But the human ability to synthesize, to understand, to optimize is still going to need to be there. So I think in many ways, the knowledge, the more fundamental knowledge of physics and maths is going to be as important as ever. The way you use it will be a little bit higher order, and it will help you to kind of take a lot of that sort of mechanical inputs that you would have had to have laboriously worked through and actually quite quickly then synthesize the opportunities and scenarios. I was just in Beijing last week, and one of our engineers was showing me this AI agent that they've built, which can actually design a lot of the vertical transportation now in buildings. So instead of spending weeks calculating, opportunities for lifts, doing scenario testing of the multitude of different suppliers that they could use, very quickly this AI agent came up with some suggested outcomes. But actually the human need was still there for him to balance up, okay, we've got these 8 options ahead of us, but actually through his deep understanding of vertical transportation, his ability to then guide that input from AI and to say what's the best way forward was absolutely needed. So don't stop on the physics and the maths just yet, but I think, the ability to use it in a higher order way is absolutely going to be there.
The error rate is still high enough that it works best with people that have deep domain knowledge to start with.
Yeah, so, spot on. Yeah. And it's sort of this word collaboration. As I'm sort of hearing myself speak tonight, I probably said the word collaboration about 20 times. We talk a lot about collaboration with humans, but actually the way I see us, and I see particularly our younger staff at Arup who are, digital natives, you can see them so comfortable. I sort of squirm slightly because for me, it's this really intentional process to learn how to use AI for me. But you can see them collaborating. It's not like they're using, this sort of, it's not this trade-off, and this pass, handover to AI. It's this deep collaboration with the technology and using those higher order skills.
Yep.
First of all, let me declare I'm a very happily retired structural engineer and enjoying my life and still doing many other things. I do know Arup because in the early 80s, the office is up in the little house up in Spring Hill. I actually worked there before, so I do know Arup. Now the question is not for myself, it's for the younger engineer, the engineering still pursuing the career. My 40 years experience, I've seen a lot of, some engineer going into law, become a great barrister. Some engineer going to MBA, become a CEO. You are the very first person that actually engineering going into architecture. Is it because of the job you in Dublin that thought, maybe good idea to go into architecture? So what sort of challenges you would have had when you started from engineering base, suddenly going to a 3-dimensional space? Not very cool for the engineer, frankly, okay? And you're great in number crunching. For 3-dimensional space are great for architecture. What sort of challenge you would have had? At the same time, for the younger engineer might think about that direction. What sort of opportunity they would have had?
Yeah, great question, and congratulations on an extraordinary career it sounds like you've had as a structural engineer. Yeah, look, it's interesting, isn't it? So I was in my early 30s, and actually, initially when I thought about going back and studying, thought about doing an MBA. That was probably the far more sort of well-trodden path. You've done engineering, go back, study an MBA, get into management. But I thought, actually, what do I love doing? It's again, this word of love, what resonates with me emotionally. And the design process was what I loved, working with the multitude of designers, really bringing them together, whether the facade engineer was saying the facade should be pink and the building physicist was saying it should be green, and then the contractor saying we'd save lots of money if we didn't have a facade. My ability, to expand that thinking was really what drove me at the time. And I had this fantastic book, probably somebody gave it to me, and it was called Engineer and Architect, A Sibling Rivalry. And it was a great read because it really talked about actually how there's often this sort of trade-off between professions, and often people are retreating into their corners. The contractors are on one side saying, for God's sake, the engineers are so, they're designing things, with such high factors of safety, it'd be so much cheaper if that, reduce the factors of safety. And the architects, the engineers are value engineering everything that's beautiful out of the building, and you sort of, this sibling rivalry was something I'd really seen and experienced. So for me, studying architecture on the back of engineering was almost that sort of taking myself out of my mindset at the stage, you know, that had been very engineering, rational, linear, and challenging myself to think differently, which has probably been something I've tried to do in my life throughout, you know, challenge your own fixed mindsets, your own sort of subconscious biases, how to get yourself out of your own head to look at these issues more objectively from as many angles as possible, to dissect and objectively assess actually what is the best way forward.
Hello, terrific talk, thank you. I've got a question. Today's theme is building the unbuildable. And I was thinking, what about growing the ungrowable? Because there's a great intersect here between building and nature at this era, I think, when we're facing climate change and loss of biodiversity and so on. So I was just interested to hear, as an engineer, a discussion around how nature might play into the designs of the future, especially, particularly with the Olympics here in Brisbane. Thank you.
Yeah, great question. No, look, and I think actually, look, I'm really pleased that nature-based design is actually far more on the agenda. Now, look, the last couple of years, I sort of occasionally do look at society more broadly and wonder whether we've had a bit of a wobble and how do we make sure that we don't wobble too far off track. But that's probably a bit bigger political discussion. But certainly, I mean, what Arup is very focused on, and certainly I've seen some extraordinary examples of, is nature-based design, but also regenerative design. So this idea that you are actually achieving a better outcome through the infrastructure and through the construction process that we're delivering. And we actually have got some extraordinary examples of that. So even I spend a lot of time up in Asia now, and I always had a major issue with land reclamation. Philosophically, it felt like a human intervention that was gone one step too far. And yet actually there's been some extraordinary examples of land reclamation at the moment where we actually have achieved regenerative outcomes in these sort of very, very complex marine environments with horrific pollution, loss of biodiversity, and actually through the land reclamation we've actually managed to seed back marine environments, ecosystems that have been lost for decades. And you know, actually, I mean, I get quite emotional when I think about it, because you think we're creating this extraordinary outcome for humans and also actually really doing deep good for the planet at the same time. So I think we need to continuously challenge ourselves to do that. And I think, you know, something I often talk about with my team and with projects that I'm involved with is how can we even do better? You know, it would be even better if, and it's sort of, you know, not accepting a solution that's simply easy to deliver, that's simply meeting the brief, you know, actually challenge ourselves. What better can we do together to lift that bar? And I think nature-based thinking, regenerative design is something that we must insist that we hold to as a profession.
Thank you for such a wonderful talk, Kate. My question is, if you had to take one thing that you learned either in university or your first few years as a graduate, or one thing you wish you'd learned, what would it be?
Oh, that's a very good question. One thing I wished I had learned. I think to probably have patience. I was pretty pacey, pretty restless as a young engineer. You know, it's sort of this sense of let's do more, not just individually, but collectively. You know, this idea of, you know, surely we could do better, we could do even better if, you know, let's deliver this at pace, let's challenge the status quo. And it's probably something that I've learned over 25 years. Sometimes, you know, it's this go slow to go fast mentality. Sometimes, you know, having a little bit of patience, you know, testing the thinking, make sure that you've really sort of peeled the layers off that onion. You know, it's sort of, don't just assume at first glance we know what's going off, but that asking questions, testing what is the problem we are actually trying to solve here. I think I'd probably tell my younger self, just have a little patience, go slow to go fast, get the thinking right, and then you'll go with great pace. So yeah, and that you could probably apply that lesson to projects, to design, but maybe even to personal development if I'm going to get really philosophical about life.
Yeah.
Can I ask a question again about AI? You've obviously thought about it. I can think of you thinking of nightmare scenarios in the middle of the night. We know that AI is advancing very, very rapidly. It's not very difficult to consider a situation where AI can replace structural engineers and civil engineers and even chemical engineers. What happened? What do you how have you thought about that, and how do you think we will survive, or whether we'll all end up in a heap?
Yeah, no, and I completely understand the sentiment of your question, and look, a number of my engineers ask me the same thing. Actually, we had a really interesting Q&A last week in Beijing on this, because, you know, as this senior engineer, actually he was a structural engineer by training, presented this AI agent that he had designed to do the vertical transportation in this building. You know, you can see all the vertical transportation engineers saying, well, there goes my job, you know, it's sort of... But it's not the case. I think it will mean, I think there will be a productivity uplift, there will be efficiency. So it won't take us as long. Things that we might have spent a week doing calculations for, we might be able to do it in a day. So I think there will certainly be productivity improvements, but I think that it's going to be then a question of how do we use the humans, and how do we then actually do even more with the human input. So I'm a great believer that the human will not be replaced by AI. I think we need to make sure that our ways of working with AI keep pace with the technology, and I think that is a challenge. I think I certainly see at the moment the technology, and I mean, you read about it in the news, don't you? I wake up every morning and read the ABC News online, and sort of there's, you know, some new thing from Anthropic or someone about, you know, AI agents sort of, you know, waking up and hacking into companies and so forth. And certainly there is risk if we don't handle it properly. I think certainly what we're seeing on projects and with clients now, our ways of working speak to the old ways of design. So we are going to have to collectively, as clients, as standards that we work with, of workflows that we work with as clients through the construction project with designers, we're going to have to work on how we actually, you know, change and adapt to AI. But I think the human will fundamentally have a higher order role and a key ingredient. As a structural engineer, I deeply believe the structural engineer will always be needed. We won't be replaced, but we will be augmented, and that's not necessarily a bad thing.
Can I ask a follow-up question? Yeah. Once you've got the situation where AI can do all of those things that a structural engineer can do, not picking particularly on structural engineers, there'll be a tendency for the structural engineer not to go into the detail.
Yeah.
So how will you know that the AI has got a building that's not going to fall down?
Yeah. I think we could talk for hours on this topic. I think there's a really important point, and, you know, somebody challenged me the other day of, well, you know, surely if AI is here, you know, in the younger years, you know, you'll be able to get AI to do a whole stack of the tasks that young engineers would usually learn through. So you're going to suddenly lose that really important learning in the first 5 years of a professional's career. Well, as an employer, and certainly as someone who's got a vested interest in making sure that the staff who 10, 20 years hence have got the capability to have that higher order impact, we can't lose that. So there might be, and actually I was talking to somebody in the legal profession the other day, and they're finding exactly the same. Actually, you need to continue to train people, you know, to the maths and physics. There might be some things AI could do that you think, oh, well, then I don't need to learn how to do that myself. We will still need to do some of that learning, that there might be a more efficient way of sort of working around. We will need to do that so that 5, 10 years hence, they've got that sort of core foundational knowledge that they're needing to do those higher order activities. And we've certainly talked about that at Arup, and we've talked about the professional learning and development that we still need to give our staff in how to use AI, but actually how to operate without AI as well. So no, it's a great question, really good reflection.
Okay, so we have time for one last one.
Thank you for your presentation. I really enjoyed listening to it. You mentioned throughout that Australia has a lot of ambitious infrastructure projects coming in the next few decades, especially with the Brisbane Olympics. And you mentioned building legacy. So what does a successful Games look like 10 years after? What does that look like to you?
Great question. And actually, I just, right before I came this evening, met with one of the legacy, she's in government, and her job is basically to deal with legacy for the Olympics. And I think, what we were talking about this evening, this amazing lady and I, legacy will be in so many different shapes and forms. It will be in the physical infrastructure, the housing, the green space, the public space, these, incredibly improved transport systems and networks that we will have built. So there is the ultimate, design case that you're designing for in this infrastructure that will absolutely therefore be available. But it's more than just the built form. And one of the things we were talking about, and particularly with my role leading in Asia Pacific, she was saying it's a great opportunity for Brisbane to become far more connected, far more visible to Asia. So actually what an incredible opportunity for Brisbane to effectively say to this whole Asian market, we're here, actually we have got so much to offer as a city for tourism, yes, of course, but actually beyond tourism. So I think legacy for me, it comes in so many different shapes and forms. And again, I think that sort of pausing to reflect, giving ourselves to sort of spend time together and, conversations like this afternoon that I had with this lady, actually, testing what does legacy really mean and how do we make sure through all of these forms, we were talking about Asia City Summit and hosting that in Brisbane next year, to really start to kind of seed before the Olympics, through the Olympics and after the Olympics, actually how can we build legacy so that there is this thriving city, but there's actually also a thriving economy, a thriving social construct, and a thriving environment to the point on regenerative design. Yeah, great question.
Right, so that's what we've got time for. I think it's really interesting that we're at the Frank White lecture and we're hearing about Arup as well. And so we're talking about two people that have had obvious ongoing legacies, both because they were technically brilliant, but also because they're exceptional with people. And I think for everyone in the room that's thinking about your own legacy, those are two really good things to take away from the evening. So now we're finished with the formalities, and so we'll have opportunities for more drinks, some more unstructured conversation, and just general mingling. So let's thank Kate once more for just a fantastic session.
Thank you. And thank you so much for a great Q&A. And thanks again to the University of Queensland for the invitation. And it's been an absolute privilege to give this address for Frank White Memorial Lecture this evening. So thank you very much.
Thanks. Thanks, Kate.